918 words, within the 855-945 target range. Here's the final script. Right now, Wolf-Rayet 104 is still spinning 8,000 light-years away, a dying star locked in a slow, deliberate turn. And that turn is aiming something at us. Astronomers at Caltech found it by accident. They have no way to stop it, no way to know exactly when it fires. And what happens if it does could be the last thing some of us ever see coming. But here's what nobody is telling you about what's really pointed at Earth right now. Gamma-ray bursts are the most violent explosions in the universe, brighter for a few seconds than every star in every galaxy combined. They were first spotted by accident by American satellites built in the 1960s to watch for secret nuclear tests. Instead, they caught flashes coming from deep space, and nobody could explain them for decades. They come from two places: a giant star, dozens of times heavier than our sun, collapsing into a black hole in an instant. Or two dead stars, spiraling closer for millions of years, finally colliding. Either way, the result is the same: a beam of pure gamma radiation, fired out like a blast from a cosmic shotgun, narrow, focused, and unimaginably powerful. Wolf-Rayet 104, a star near the end of its life, boiling off its outer layers into space, sits in the constellation Sagittarius. And its spin means that beam, when it comes, will point almost directly here. Here's the part that should not be possible. Scientists calculated the odds of a star like this actually lining up with Earth. The number was small, comfortably small. Then, in 2008, a team using the Keck Observatory looked closer at the pinwheel of dust WR104 throws off as it spins, and the geometry didn't match what they expected. The tilt was steeper, far steeper. Steep enough that instead of missing us by a wide margin, the beam's true path sat far closer to a direct hit than anyone had modeled. Suddenly, a star nobody worried about became one of the most watched objects in the southern sky. Not because it was going to explode tomorrow, but because, for the first time, the math stopped being reassuring. Naturally, scientists reached for an explanation. Surely the star is too far along, too well understood, its future too predictable to be a real threat. Except Wolf-Rayet stars are famous for one thing: they don't die on schedule. Their outer shells are unstable, shedding material unevenly, which means predicting the exact moment of collapse is close to impossible. Caltech researchers admit they cannot say if WR104 will detonate in 10,000 years or 10. And distance, the thing we usually count on for safety, stops mattering at this scale. 8,000 light-years sounds far. For a gamma-ray burst, it is uncomfortably close. Close enough that some scientists now argue the safe distance they once quoted was never safe at all. Here's the strange part: it shouldn't even be aimed this way. Statistically, a direct hit from any single Wolf-Rayet star is supposed to be a near impossibility, 1 in thousands odds stacked against it. And yet the geometry, the tilt, the spin, all of it lines up uncomfortably well. Now the deep revelation. In 2004, a gamma-ray burst named GRB 41219A produced a signal so intense that instruments briefly saturated, unable to even register its true brightness. That burst wasn't aimed at Earth. It grazed us from an angle, and it still lit up detectors like a flare going off next to the lens. Scientists ran the numbers on what a direct hit would look like from a source at WR104's distance. The conclusion they don't like repeating out loud: it could strip away most of the ozone layer in the hemisphere facing it within seconds. Not damage it, strip it. UV radiation would flood in unfiltered. Marine life at the surface, the base of entire food chains, could collapse within a season. And there would be no warning, no siren, just gamma radiation arriving at the speed of light, faster than any alert humans could send. This is where it stops being an astronomy story. If WR104 is even close to aim the way the data suggests, then the thing standing between us and a mass extinction event is a coin flip in stellar geometry we didn't get to vote on. It means the universe doesn't need a malicious asteroid or a rogue planet to end an age of life on Earth. It just needs one dying star, already spinning, already leaking gas into space, to finish collapsing at the wrong angle. Every physics model we use to predict existential risk now has to include a variable we can't control, can't observe changing in real time, and can't stop once it starts. Some researchers have quietly floated the idea that a nearby gamma-ray burst millions of years ago may explain a mass extinction already buried in the fossil record. If that's true once, there's nothing stopping it from being true again. That is not a comfortable rewrite of the textbook. It is a very quiet, very permanent one. So Wolf-Rayet 104 keeps spinning. Caltech keeps watching. And nobody, not one astronomer on record, will tell you on camera exactly how much time we actually have. Is the tilt getting worse? Or is it, tonight, already close enough? Tell us in the comments what you'd want to know first if it were true.